Hi and welcome back. In this video, we are going to see that how to find the middle node of a linked list in general. The linked list may be the single linked list or the double linked list, right? So let us say you have a single linked list or a double linked list, then we are going to see the algorithm or the method that how to find the middle node of the linked list, right? Okay, so let's get started. So basically, to find the middle node of the linked list, we have two approaches. First approach is quite straightforward. So the first approach is that we just need to traverse the linked list, and then we'll find the total size of the linked list, and after that we will traverse again the linked list from the head pointer until we reach the n by 2th node, right? So by this way you can find the middle node. Okay, this approach is simple approach. The second approach is called as a two-pointer approach, which is the efficient one. Okay, so what's there in the two-point approach is that we will be having two pointers, right? And with the help of those two pointers we will be able to find the middle node. Okay, so we'll discuss this approach in the later part of this video, right? So coming back to the first approach once again. So in the first approach, what we'll do is that we'll just need to traverse the list until we reach the n by 2th node, right? So first we need to determine the size of the node, size of the linked list, and then we need to go to the n by 2th node to get the middle node. Okay, now let's see that what is a two-pointer approach. Okay, so as I have told you that in the case of two-pointer approach, we are going to have two pointers. So the first pointer will be slow pointer and the second will be the fast pointer. Okay, so as the name suggests, the slow pointer is going to move slowly in comparison to the fast, right? So the slow pointer moves one step forward, then fast pointer will move two steps forward, right? Okay, so we'll traverse the linked list from the head, and when the fast becomes null, then the slow will be pointing to the mid node. So the algorithm goes like this. So you start traversing the linked list from the head. Okay, so initially the slow and fast pointer will be pointing to the head only, right? So you start traversing. So when the fast moves two step forward, then you need to move slow one step forward only. Okay, so once the fast becomes null, okay, then in that case the slow pointer will be pointing to the middle node. Okay, so we'll just have a implementing, right? So as we have discussed, there are two approaches. One is a simple approach and the second is two-pointer approach. Okay, so in the first approach we need to find the size and then go to the n by 2th node, and in the second we need to do this. We do not need to do these kind of steps which we are doing in the first approach, right? So let's focus on the two-pointer approach, which is a new to us and which is also a efficient approach, right? So in the two-pointer approach, let's say we have two cases, right? So when n is odd and when n is even. So n is the total number of nodes present in the linked list, right? So let us focus on the first case, which is saying that n is odd, right? So when the n is odd, at the starting, the slow pointer and the fast pointer will be pointing to the node, to the head. Okay, and so after first iteration we will move fast one step forward, then again we'll move fast one step forward. So if you see here, the fast has moved here and the slow has moved one step only, right? So if you see this position and then you come back to this position, then you will find that the fast has moved two steps, but the slow has moved one step only, right? So this is how the fast and the slow pointer is moving, right? So now if I again move fast here, then the fast becomes null, right? So in that case the slow is pointing to this node and this node is the middle node, right? Okay, now let us take when n is even, right? So again we start off from the head node only, and again I move fast one step forward. At that point we are not going to move s to the next step, because whenever the fast is able to move to the move two step forward, then only the slow will be allowed to move to the to next step, right? Okay, so when the fast is moved two steps, then we have moved this slow one step forward. Again we move fast as one step, and then again fast as two steps, right? So the fast has become null, and when this fast has become null, that means at this point the fast has moved two steps forward, right? So again we'll allow this slow to move here, and now this fast has become null, so the slow pointer is pointing to the middle node, so this will be our middle node. Okay. Okay, fine. So now let's go back, and now we'll write the code for this approach. Okay, so we'll go back to the Studio IDE. So let's go there. So you can see we are in the Visual Studio IDE, and I have my simple or basic code written. And what does this code do is that this code creates a single linked list. Okay, and this function is the function to print the list. So this code we have discussed in the previous video in the series of data structures and algorithms. Okay, so now we'll be calling, right? So let's say calling the function, so calling the function to find the middle node. Okay. Okay, so in that case, let us see what is going to happen. So of course the return type of that function should be struct node star, because we are expecting the address of the middle node. Okay, so I'm going to call that function as find mid, and inside that I'm going to pass the head pointer. That's it. Okay, now I am going to define that function. So defining the function to find the middle node. Okay, and the return type. Okay, the return type of the function will be the struct node star. Okay, so we'll just quickly define our function, which is find mean, and the parameter is only one, which is nothing but it's pointed to the first node, which is a head. Okay, so we'll have some corner cases, right? So let's say if head is equals to null, then we just need to return null, right? Because in that case there is no middle element, right? If there is only one element, then in that case this will be equals to null, right? Okay, so this will be equals to null, and in that case we just need to return the head. Okay. Okay, fine. Now coming back to the general case, what is the general case? So to apply the general case, we need to define two pointers which are slow. Initially it will be pointing to head, and another which will be let's say fast, which will be pointing to head again. Okay, now we'll use while loop, and inside the while loop the condition should be that fast should not be equals to null. If it is not equals to null, then we'll first move the fast pointer by one step, then again we'll check if, right? So if star fast dot next, or we'll check simply check fast is not equals to null again, then we'll move fast as star fast dot next, and then we'll allow the slow to move as star slow dot next, right? And once you come back, so you just return the slow pointer, because the slow is the pointer which will be pointing to the middle node. Now coming back, you just print this, that the middle node will be like this. So you just print star mid dot data, and you just have a new line. Okay, now let's just compile it. Okay, so first I'm going to go to the directory. Okay, let's just make it to the full screen, and then I'm going to do kind of g++ minus o, and yeah, the name of the file is link.cpp. So you can see it is giving some error. Okay, so the function name is wrong here. So let us say, where is my function name? It is not min, it should be mid, right? So we'll delete it and we'll save it. Again we'll go back to the original terminal, and again we'll try to compile it. So you can see it has compiled for the pop-up message. So first we are going to create a single linked list of size 5, and the elements I want to enter are 1 2 3 4 and 5. So the expected output should be 3, which is the middle in this case. So you can see the 3 has been outputted onto the terminal. Now let's take another say the case when n is even, and the elements I want to enter is 1 2 3 4. In that case, in this case, the expected output should be 3, right? So you can see it has been 3. Okay, so if you do note here, what we're doing is that when n is even, right? So in that case we can take either 2 or 3 as the middle element, right? So in this case I am taking 3 as the middle element. Okay, now if you want that you get 2 as a middle element, in which we assume generally. Okay, so we need to make some changes in the code, right? So let's come back to the code here and we'll just make change here, right? So here you can see that we are checking that when fast is not equals to null, then we need to move the slope pointer. Now we'll just add one more condition with the AND operation, that also if star fast dot next is not equals to null, okay, then that means if both these conditions are satisfied, then you move the slope pointer. Okay, okay, now let's just save the code and go to the terminal once again, and we'll just have these cases once again. Okay, okay, so we'll just run that case, just wait for the message again. And okay, so message come, let's check for n equal to 5 once again. So you can see it is working fine. Let's check for the n is equal to 4. You can see it will also work fine, and it is working fine, right? Now let's just check one corner cases. Let's say the total number of nodes is 1 and the element I entered is 1. You can see the 1 has been printed, right? So this was whole about finding the middle element into the linked list. Okay, so you can apply this concept either in the case of doubly linked list or in the case of a singly linked list also. Okay, so I hope you have understood it. Okay, so if you have not understood it, then you can please go back and see this video once again, and if you have any doubt, then you can ask me in the comment box below, right? Okay, so and also if you have not accessed my playlist on the data structures and algorithms, then please do that. Okay, you can go to my channel and you can access this playlist of the data structures and algorithms. In this I have discussed the sorting algorithms, and basically my motive to make this playlist is to provide you all with the code. Okay, code. Okay, like how to or the code to implement all the data structures and the code to implement all the algorithms, right? So you can find the C++ program for implementation of all the data structures and algorithms in this playlist. Okay, so if you have not accessed this playlist, then please do so. And also if you like this video, then please like, share and subscribe the channel. So I hope you have understood all these concepts. So that's it for this video. Thank you and Jai Hind.